turn the air off before we leave, like a half an hour before we leave, they turn the air off. And I think that's cruel and unusual punishment. I think it's because the days are longer now. You know, we start later, so we end later, and they haven't adjusted the air conditioners from the previous years. It's crazy. That's all going to be on the beginning of my video because it started recording. And so they're going to hear me complaining. Like anyone who watches the video is going to be like, man, she's complaining. What's she complaining about? And what it is that I'm complaining about is graphing because nobody likes graphing, not even me. Ooh, that's a big pen. I actually do like graphing. I like how much you guys don't like it. That's my favorite part. Just kidding. So we're talking about graphing of equations, right? So this is section 1.2. This is going to be part 1 of section 1.2, and it's graphing equations. Graphing of equations, graphing equations. We are just going to get into the very basics of graphing today and how we know I am plotting something. Thank you. Um, and the very basics in graphing, we need to first start with how do we know if a point works, right? So if I want to determine, this is before we even get into the graphing, right? To determine whether a point is on the graph of the equation. Determine whether a point, it's so much easier to say than it is to write. A point is on the graph of an equation. All we have to do is take the equation and plug the point in to see if it makes a true statement. So if I want to determine whether point A, we'll call point A 213, and point B -1, -3, and if I want to know if those points fit or lie on the equation, I wrote it down. It sounds like I'm making it up as I go, but really, if I want to know whether they lie on the graph of the equation y equals 10x minus 7, I just need to plug them in, right? We know what x and y are, right? We know that x is always this first value and y is always the second value, right? So if we just plug those in for x and y, if the statement that we get back is true, then that point does lie on the graph of the equation. We know that it's a valid point in that equation. So if we look at this, we'd say, well, y, that's just 13, equals 10 times x. Well, x is just 2 minus 7. And if we get back a true statement here, then it's true. 10 times 2 is 20 minus 7. Well, that's 13 equals 13. So this is true, which means that this point would lie on the graph of that equation. If we tried with this one, if I have my y equals 10x minus 7, look, my y is so different here than it is here, and yet I use those interchangeably all the time. Let's try with this one. Here we know that y is equal to -3. 10x, well, x is -1 minus 7. So that's going to give me -3 equals -10 minus 7, or -3 equals -17. This, not true. So it is not a solution. That point wouldn't lie on the graph of the equation. So when you see a graph of any equation, every point on that graph, right? Like if I have a graph, right? and I graph an equation. We're going to make it a linear equation. We're not even going to discuss what the equation is. Um, say this is the graph of the equation, right? It's linear, it's a negative. Every point that this line touches is a solution for that equation. It's got an XY value that fits that equation. Anywhere that blue line touches and I stop, right, is a valid point in the equation. It's an XY value that fits that equation and will be a true statement. Does that make some sense? Okay. So I'm not going to make you do this on your own. You will have to do it on your own in WebAssign, but like I'm not going to make you do one right now, even though I set one aside that says you do. I'm going to have you do it, but I feel like that's a fairly basic thing. It's easier for us to move on to the next step because that's just a piece of information. We need to move on to point plotting. There's several ways that you can graph an equation, right? The first and most um, I should say the first and most least informative way is just plotting points, right? But it's what we first learned how to do to kind of understand how graphs work. So we're going to do some plot pointing, point plotting. Got it backwards. So point plotting, ultimately, what you're going to do is if you have an equation, you're going to try, if you can, to isolate a variable. Isolate one variable. Does anyone know what that means? Yeah, kind of. It's lonely, right? If I have an equation, sound of silence. If I have an equation, right, I have something set equal to something, right? Um, when you're isolating a variable, it means it's going to be the only thing left on one side of the equal sign, right? So if I'm isolating an x as my variable, the only thing on that side of the equal sign is going to be the x, and everything else is going to say x equals, and it'll have all that mess behind it. But the x is all by itself. So that's what isolating a variable means. It means get it by itself. Um, then you're going to construct a table of x, y values. We're going to construct a table of x values, right? And then you're going to plug those x values into your equation, and it'll give you y values, right? So construct a table of several solution points. So I spelled several. That's supposed to say several. It doesn't. I was just adding letters to the word several. Then 3, you are going to plot the points on a graph, right? What kind of graph? A rectangular graph, a Cartesian coordinate plane. And then 4, you are going to use a straight line. You're going to draw a line or curve through them. Draw a line, or they like to say smooth curve. That's how they say it in the book. So I'm going to say smooth curve, right? To connect all the dots. What does that look like in real life? Well, it looks like, well, I'll tell you what it looks like. Oh, that is not what it looks like. That's a really big line. It looks like um, if I say to sketch 3x plus 4 equals 7. Oh, sorry. I can't read my own writing. It's 3x plus y equals 7. I'm like, where's the other variable? I gotta have two variables to make it work. So if I were to sketch 3x plus y equals 7, I would isolate one of my variables. The easiest variable to isolate right now is y, right? Because the y doesn't have anything being multiplied to it. So I would isolate that variable by subtracting 3x from both sides, and I would get y equals negative 3x plus 7, right? And then I would construct a table, which you guys have done before in your lives. It's like the earliest, most rudimentary graphing that you guys did, like when you were first learning to graph. But you might forget because I know y'all hate graphing, right? Right, I know this. Now, when I make a graph, I like to have a variety of types of numbers. So I'm going to go like -3, -2, -1, 0, 1, 2, 3. Actually, if it was me, I'd skip the threes. I always think that like 5 points is enough, but this is how the book did it, so I'm going to do it this way. Well, where do I get my y values from? If I that the x's are arbitrary, right? I could pick any numbers I want. I'm going to pick some negative numbers. I'm going to always throw in 0. I'm pick some positive numbers, right? So I could see kind of how the graph goes, like whether the numbers are negative, whether it's 0, or whether it's positive. I can kind of get a feel for what the graph is going to look like. But where does y come from? How do I find my y values? The math god, yeah, that's important. The equation, yes, but how do you mean? Sort of by solving it. Well, the 7 is part of the equation. I know what you're thinking of there, Kevin, and you're not totally off on that. You're thinking of the y equals mx plus b, giving us some clues. But we're way before that right now. We're just talking about the most rudimentary of things, right? Here, each one of these is an x value, right? And if I plug those x values in, I'm going to get a solution for y. So if I have -3x, well, what if I make x -3, right? Plus 7, I would get 9 plus 7, which is 16. So now I have y equals 16 when x is -3. And what does that give me? That gives me a point. I have a point on the graph that's -3, 16. That's what each of these are creating, is a point on the graph. And then I do the same thing for -2, right? I go y equals -3 times -2, because that's what x is, plus 7. And I would get 6 plus 7 is 13. And so I'd know that here y is 13. And am I going to do the math on all of these? Well, in real life, you would, but I'm not going to, because I have them all written down right here. So I'm just going to go ahead, now that you know how to get them, and get 7, 4, 1, 7, 4, 1, -2. And then all I'd have left to do is to plot each of these points, right? Each one of these is a point. This is an XY value point. This is an XY value point. And we could plot all of those points on the graph, right? And it'd be pretty easy, except for like, these are some big numbers, but we could still do it. We just count by twos instead of ones, right? I'm gonna make an ugly graph right here. I'm gonna, this, we'll call that 2, we'll call that 4, 6, 8, whatever. That's a 6, pretend. -2, -4, -6. We'll call this -2. Call 2, 4, 6, 8. Heck, that's going to take me forever. But you guys get the idea, right? 10, 12, 14. Oh, let's make this 16 up here. Right? And I can plot every single one of these points pretty easily, right? I've got -3, 16. Well, that's going to be up here. I've got -2, 13. So -2 goes to 13, which is between 12 and 14. I have -1 is going to take me to 10, which is like right about there. 0 is going to take me to 7. 1 is going to take me to 4. And I'm creating this line, and it'll be a line on this one. It's linear because there's no power on it, so I know it's going to be a straight line. What do we have now? We have 2, 1, and then we have 3, -2, right? And we've created this line. And if it was a perfect world, then I didn't hand draw this, but most of you are used to my ugly graphs because you had me last year. So you know I can't draw a straight line to save my life. But you get the idea, right, of this graph, and it's just plotting points. But can you see any problems with trying to graph this way? Can you see why it wouldn't be the ideal situation for graphing? Envy? Calling it Envy because I can't see her. And Miguel, your camera needs to be on. Well, first of all, I picked a series of points, right? I started with X's. I could pick any X's I want, right? But how do I know if that X is even on the graph, right? I could start at -3, but the graph is all the way down at like -47, right? And it never actually gets to -3 until our Y value is like 8 trillion, right? I have no way of knowing where to start. And I don't know if Kevin was saying where to start, but he's right. It's where to start. Like, I don't know if he was going like, where do I start with how awful this is, or if he was telling us that it's where do we start, right? So there are some problems in that, right? In trying to figure this one out. Um, can it be effective? Sometimes when it's linear, right, and there's no powers, it's usually a fairly um, good way of doing it, because when something's linear, it is a straight line everywhere. You know it's going to cross the X, you know it's going to cross the Y, it's going to have a real number value for, like, all real numbers will have a value for X, right? You could plug in anything for X on something that's linear and get a straight line, right? It's going to hit every X value and give you a Y value. It might be a really high Y value, but every X value will have a Y value um, on the graph. So you could start anywhere with something linear so it would work. But there's a lot easier ways because not everything is linear. Sometimes you guys are going to get squares, right? And then do you guys remember what squares graph like? Like if I have an x squared, do you remember what shape you get with that? Yeah, you get that U shape, you get the parabola. Well, that parabola can start here, right? Or it can start over here. And by the time, and so I might want to start wherever this is getting, right? Or where it's going to cross my x axis, or where's like, So there's better ways, is what I'm trying to get at. Like for a parabola, it'd be really hard to just come up with random x values and hope we're going to find that curvature. So what we do, one of the ways we take care of that is we use intercepts. Anybody remember what intercepts are? You all should, because I taught it to you. Like breaking my heart right now. Every single one of you, like, I know I told you about intercepts. Kind of, yeah, like the axes, right? When we have a graph, I have to fix this whiteboard up so that it has my pictures so I can bring in graphs and I don't have to draw them all the time, especially since this one doesn't like straighten my lines for me. So I have an x-axis, right? And I have a y-axis. And anytime a line or a graph of an equation, no matter what the equation, let's do like that. So this is an equation, right? The graph of some equation. Anywhere that it crosses the x-axis is considered an x-intercept, right? Anywhere that it crosses the y-axis, which is only right here on this one, that would be considered a y-intercept. So you can have multiple intercepts, but knowing those intercepts allows us to graph things a little bit better. Now, we would definitely need more information than that, right? Because if I found just the intercepts, like I wouldn't know what the high and low points are, where to kind of start, but you could get an idea what the sketch of the graph looks like by finding that, right? And the way that we find intercepts is, so let's go using intercepts. To find an x-intercept, my handwriting's gotten worse this year, I feel like. I feel like I used to be much better at writing stuff on there. To find the x-intercept, we're going to set y equal to 0 and solve for x. Yeah, but not everybody has to read yours. They'll have to read mine. For the y-intercept, so if for the x-intercept, I set y equal to 0 and solve for x, the y is the opposite of that, right? So for the y-intercept, we are going to set x equal to 0 and solve for y. So if I asked you to find the intercept of that same equation, you'd be like, what equation, Miss Y? I can't see that part of the board anymore. I would say, okay, well, here we go. We've got 3x plus y equals 7. So if I want to find the x-intercept, right, let's start with x-int, right? All I have to do is set y equal to 0 and solve for x. So that would be 3x plus y, well, that's just 0, equals 7, which is just going to give me 3x equals 7. And then when I divide by 3, I get x equals 7/3. So the x-intercept is 7/3. That means at 7/3, we know that that graph is going to cross the x-axis. What would be the y value there? What did we plug in for y? Kevin got it right, 0. We plugged in, we know what the y value is because we called it 0. And if you think about that, it kind of makes sense. Like when you're graphing it, right? Say this is my 7/3 point right here. Well, what's the y value? Anytime you're on that line, your y is 0, right? Because you're not going up or down from that line, right? So anything on that line for y is going to be 0, because y is basically counting your distance up or down from that x axis, if that makes sense. So we found our x-intercept. Now all we have to do is look for our y-intercept, right? And we do that. This time we're going to set x equal to 0. So if I have 3x, that's 3 times 0 plus y equals 7. Well, 3 times 0 is just 0, and we get y equals 7. So the point there would be y equals 7 for that intercept. What would the x value be? Valerie, what's the x value on this one? Yeah, it's 0, right? Because that's how we found it, right? We made x 0. And so when I have these 2 points, right? I already plotted this one, right? We called this 7/3 0, right? We'll call that 7/3, which is about right? It's like 2 1/3. Our other point's going to be at 0, 7. So say up here at 7, I have another point, right? And when I connect those with a straight line, that's all I have to do to graph it, right? Because I have the point that goes through x, and I have the point that goes through y, and I can make any line with 2 points, right? But they're not always going to be a straight line. So we want to look at what happens when I'm really getting through this stuff. So I only have one more example for you guys because I want you to see one where it's squared. I thought I was going too slow, and it turns out I'm not. We're making good time here, except for I still don't know how to use this stupid whiteboard. So if I have y equals x cubed minus 4x, and I want to solve that using intercepts, right? I want to find the intercepts. I can tell you that I'm going to have more than one x-intercept, and the reason I know that is I got that x cubed there, which means I'll probably have more than one spot where it crosses x. But we're still going to solve it the same way. When we want to find our x-intercept, we're going to take that problem and we're going to set y equal to 0 and solve for x. So I'm going to have x cubed minus 4x equals 0, right? I just put my y on the other end so it's a little bit more readable. Now, how do I do that? How do I solve for x like this, right? Well, I know that each of these pieces has an x in it, so I'm going to factor that x out, and I'm going to be left with x squared minus 4 equals 0. And I can set each of these factors equal to 0. So if I set this factor equal to 0, I just get x equals 0. Then I also have x squared minus 4 equals 0. So I'm going to add 4 and add 4 to both sides, and I get x squared equals 4. Do you guys remember what the solution to x squared equals 4 is if I take the square root of both? It's the square root of 4. It is, but what else is it, Kevin? You guys remember if I take the square root of both sides, here I get x. And Kevin already stated that 2, the square root of 4 is 2, but what else is it? If I multiply -2 times -2, don't I also get 4? Remember, it was plus or minus 4. So it's 2 or -2. So we have three intercepts, right? We have x at 0. So 0, 0. We have x at 2, 0. All our y's are 0, right? Because these are x-intercept. And we have -2, 0, right? Those are all points on the graph, right? There are intercepts. What about our y-intercept? Now we already kind of got our y-intercept based on this, but let's do the math behind the y-intercept, right? I want the y-intercept. This time we set x equal to 0 and we solve for y, right? So I'm going to write it the same way. I'm going to go x cubed minus 4x equals y. Only this time, wherever there's an x, we're going to put in 0. So we have 0 cubed minus 4 times 0 equals y. But 0 cubed is 0, and minus 4 times 0 is 0, so I get 0 equals 0. So my y-intercept is at 0, 0. So you see how I said we already had our y-intercept? Does that make sense to why we already had it? Because we already had this y value as 0. So what does it look like when we graph it? And I'll tell you, this isn't perfect either, but there's ways to make it perfect later on. Once we know a little bit more about how to find vertexes and stuff like that, but we're just being asked to sketch, right? So I'm going to draw a graph. Crappy one, as usual. But what do I know about my points? I know that we'll make these each worth 2, right? So at -2, -4, 2, 4, we'll call this 2, 4, -2, -4, -2, -2, -4. Sorry, these are positive. Right? If I was going to plot these points, right? We have our intercepts. We can easily plot them, right? What do I know? I have a point at 0, 0. I have a point at 2, 0. And I have a point at -2, 0. My y-intercept is 0, 0, so we've already plotted that point. And it's going to graph. Here's where we do our smooth curve. It's going to graph something like this. Only it's actually going to go through those points. It's not going to miss them because, like, most things draw better than I do. Now, there's other pieces of information that are missing here, right? Because we're just doing the most rudimentary graphs. Like, we would need an idea to go, well, what direction is it going to go? Like, when is it up? When is it down? And there's ways to figure that out. There's ways to know, like, where the turning point is, that vertex. We're not even worrying about that today. We're just talking about sketches, like the most rudimentary graphs that we can think of, right? And we're not even going beyond intercepts today. All of your work, your assignment, which will be put up, is going to be based on these two pieces that we've gone over, right? You're going to have some stuff where you're going to have to determine whether a point works in the equation, right? Whether it lies on the graph of the equation, where you just plug the point in to the equation and see if it's true, right? Then you're going to have somewhere you have to plot some points, right? And you're going to have to come up with those. I don't know on WebAssign if it'll give you X values or if you have to come up with X values and then find the Y values. WebAssign's pretty good about, like, just giving you a series of X values that'll work, and then you can find the Y values. They're also really good about having a graph there for you, so you're not going to have to draw your own graph. So say you come up with something that doesn't fit on the graph, rethink your solution, all right? Because maybe your math is a little wrong, because they give you graphs that fit. And then you're going to have somewhere you have to find the X and Y intercepts and graph those. The good news is WebAssign's really good about this. It might take you a little bit to kind of understand how to graph in WebAssign, and I'll make sure to have some tutoring time available for you guys just in case. on that so that if you want to go over how to do things in WebAssign, we can always do that. Um, I'm not going to assign you too many problems, at the most like two of each kind. So you're not looking at more than like six problems, because I know some of these can be a little time consuming. But you guys have done all this before, right? None of this is new for you. It's just that as we move into pre-calculus, they get a little bit more complex because we're dealing with cubes and stuff like that too. But I think you guys can handle all of this. But um, I'll have some tutoring time available next week for sure in case you guys need some help. Okay. Any questions about any of it? David, did you have a question? Barrios? Okay.